Hello, everyone, and welcome to my presentation on leveraging machine learning and IoT to protect vulnerable ecosystems with a particular focus on experiences from Kenya. My name is Ciira Maina. I'm a lecturer at Dedan Kimathi University of Technology in Nyeri, Kenya, and I'm also part of a grassroots organization that deals in capacity building in machine learning and IoT in Africa, known as Data Science Africa. I'm really excited to be here at the DevSummit, and I look forward to a nice interactions with you. So the motivation for this work is describing today is the fact that all over the world, a lot of ecosystems are being damaged, and we are actually facing the consequences of this environmental degradation. So you have a lot of cases where the extreme weather events. Right now, in the west coast of America, you have very large forest fires. Last year in March in Mozambique, we had devastating floods as a result of a tropical cyclone. And all these are attributed to the fact that we have environmental degradation going on and climate change. And all these things are actually affecting human livelihoods. Human life is a huge cost to life, huge cost to livelihoods. So, for example, in the tropical cyclone that affected Mozambique, these are already people who are vulnerable, and then their livelihood has been destroyed. And this is affecting us all over the world. So, in order for us to be able to stem the tide and also perhaps start reversing the effects of climate change and also the degradation of our ecosystem, we need to keep monitoring these ecosystems, and we need to know which ones are in a state that are vulnerable and which ones need perhaps remedial steps to be taken, conservation efforts to be stepped up. And this now calls us to really have a good idea of what's happening in all ecosystems all over the world. And of course, this is a bit difficult to imagine. So what happens now currently is that experts go into these ecosystems, be they forests, savannas, or any natural ecosystem there, and they do surveys on the species that are present, plant and animals, and then repeat these surveys over time and determine there are certain species of animals or plants that are disappearing. What are the population trends? But you can imagine that this is quite difficult to scale. If you're trying to do a survey in a particular ecosystem, that's going to take expertise. The expertise is hard to come by. It's also going to take a lot of time to perform this. And you can't really do this over all ecosystems. And we really need to leverage technology. So one thing we've been really looking at our university is this idea of acoustic ecosystem monitoring, where what we're trying to do is to get an idea of what's happening in an ecosystem by listening to it. So really just finding what are the sounds in that ecosystem. So if you walk into a forest, you'll hear lots of sounds. Species vocalize, and especially species such as birds make noises which are able to tell us this is a particular species, and we can determine its presence simply by hearing its vocalization. So we focus on this idea of focusing on an indicator species that will help us know what's happening with the entire ecosystem just by focusing on that species. And it's been shown, ecologists have been doing this for years, where we focus on bird species, monitor them, and determine their trends. And if we can see trends, decreasing trends or species that were once there disappearing, then we can tell that this ecosystem is perhaps there is something going on there. So it could be that people are cutting down trees, there's been human encroachment, and that's an ecosystem that may need some intervention. So experiments that we've performed have been, at our university we have a conservancy. And so we mounted some acoustic sensors there based on a Raspberry Pi. So we've also done work using the audio mode, which is a more robust system, which is lower power and can also last in the wild for quite some time. And it's designed to listen for this application of acoustic ecosystem monitoring. So when we collect this data, the idea is to then be able to use the data to find out what species are present in the ecosystem via their vocalization. So where we've been doing our experiments and mounting our sensors has been in Kenya. This is where Dedan Kimathi is based, and we have a lot of conservation areas. So the map you see there in the middle is the map of Kenya, and right there in the middle in the box is the Mount Kenya National Park, and we've been able to mount some sensors there. And if you see on the right, there's a little block that's orange in color. That is the Dedan Kimathi University Conservancy. So this has served as our playground, so to speak, where we've been testing this acoustic ecosystem monitoring technology and deploying sensors there. So this is a close-up of where we've actually done this sensor placement. So what we do is we try and replicate the acoustic, the bird species monitoring that would be done by an expert ornithologist. So what usually happens is an expert would stand at one particular point in the forest and listen and look out for birds for about 10 minutes. And that is both look and listen, and then move to a place that's over 200 meters away. So we were able to mount sensors in around 10 locations within the forest. It's a really beautiful forest. You see our pictures of rivers within the forest there. And, but it's actually quite tough to do this sort of experimentation. And at the end of it, what we have is a lot of acoustic recordings, a lot of data collected from this point cloud. These are where the expert stands at one spot, listens and looks out for species. And you can look at that as being the ground truth. Those are the species that are actually seen there. And then our sensors, since they're there over a longer period of time, they can capture species that maybe were not had when the individual was there collecting data. So we collected quite a bit of data, 20,000 acoustic recordings. And the idea is to be able to get a picture of what's happening in those ecosystems before we automate the process. Okay, so when we get this data, what we actually get are audio recordings. And audio recordings can be transformed into pictures. So here you have, this is one of the recordings from the Mount Kenya National Park. It's a recording of a brown woodland warbler. And you can see it has a particular spectral signature. So this spectrogram tells us how the energy of that acoustic signal is distributed in the frequency domain. So in terms of frequency, we go from 0 to 8 kilohertz and over a period of 10 seconds here. And we see that this image tells us this is a signature of this particular species. A different species would have a different signature. So the idea here is to then move to machine learning. Because once we have this data, we've collected the acoustic recording, we're able to convert it into an image, we can do classification. Just like you were able to see that picture is unique, the machine learning algorithms can be able to classify that among other species and differentiate them. So we experiment with things like support vector machines, random forest, and even convolutional neural networks. And here, because the data we have is not really that much, even though we have 20,000 recordings, only around 1,000 are annotated by an expert. And this expert is saying, in this particular recording, this is what I have had. So we need more data. And luckily, there's a lot of effort in citizen science to just collect data that can be used for this sort of application. And there's a website known as Zinocanto, which is good for sharing bird sounds from around the world. And what we do is we get this data and use it to pre-train neural networks, and then we fine-tune those neural networks using data that we've collected from our local environment. So this is what we have here. So when we do that, we can see results for various species. So These species are common in Kenya. Things like the Atlas turaco is a very important species. And we can see that, for example, a neural network, the F1 score is a combination of the precision and recall. And really what you would want is for this number to be close to 1. When it's close to 1 for a particular species, you're happy with the classifier. And so species such as the Atlas turaco are well identified using convolutional neural networks. And even the cinnamon bracken warbler, which is the species for which I showed you the one I showed you was actually a brown woodland warbler. You can see that for the random forest, the performance is not very good, but it's much better for a convolutional neural net. So what this shows us is that we can train models to identify these acoustic recordings and classify the species that are being heard. The next thing to do is to actually visualize what this looks like. So when we are classifying an audio recording, what we are doing is we are running through the audio recording and classifying each frame and saying that this frame belongs to a particular species. So some species are very easy to classify. So for example, this is a spectrogram of a yellow rumped tinkerbird. And you can see right there in the middle around 2 kilohertz is a clear spectral signature. And what is shown on the top is the probability of each of the species for each frame. And we see that really all of them are classified correctly as being a yellow rumped tinkerbird. On the right, we see, however, a different scenario where the actual recording is from a cinnamon bracken warbler, but only a few frames are actually correctly classified. So the beginning frames are correctly classified, and then later other frames are classified as a tropical boo. So in short, the classification is not always accurate, and things need to be done to ensure that we can maximize this accuracy. So when we repeat the same, so we've collected data from the Mount Kenya National Park, and what we do is we then we want to be able to classify the recording. What we find is that based on our recordings, we really need to do a little bit of pre-processing of the acoustic recordings to be able to have any hope of accurately classifying our recordings. So for example, this example I show you here is from a gray-backed Camaroptera, a different bird, and you see the bottom plot here on the left shows the spectrogram without any pre-processing. It is inaccurately classified as a tropical boo-boo. So that so the yellow part shows the high probability. On the right shows the same audio signal after we have done some high-pass filtering. And after we high-pass filter, we now get a correct classification. So what we need to do is pre-process our acoustic recording. So this is what we are continuing to do. And what we're going to do is then put the machine learning models that we have on edge devices. So that's the next step we are working on, so that the acoustic sensors we deploy actually also do the classification. And that's one way we'll be able to really automate the process of acoustic ecosystem monitoring. Because at the end of the day, what you have is all recordings from a particular location are processed automatically. A catalog of the species present is obtained. And when you're able to do that over a long period of time, you're able to pick out if there are any species that are dropping out. Are any species of birds dropping out of this list that I keep seeing? And if that's the case, then it points to we need to do some intervention. So that's what we've done on acoustic ecosystem monitoring. We've also been exploring water resource monitoring using IoT platforms. And in Kenya, there's a lot of competition for scarce water resources. So water resources are used, human consumption. There's also livestock consumption. And in some cases, the competition for water is really high. And what that means is that we really need to protect the catchment areas where the rivers draw their water. These are also an ecosystem monitoring problem, but also we need to determine how much water is present in our rivers, what can it support, what can this water support, and how can we use it sustainably? Can we also detect degradation of these water resources? Because we can tell, for example, if river levels are dropping below certain levels which they were not dropping below before. So what we've done is we've developed some sensor systems based on the MDOT and using LoRa, and this an acoustic ultrasonic sensors for river level monitoring. And our idea here is to mount this on rivers of interest and monitor over long periods of time the discharge of these rivers and be able to predict using hydrological models as well what is happening. Is there a change? Are there anomalies happening? Is there something that can point to degradation of this water resource? Because what can happen is, for example, a catchment area can be interfered with and leading to things like flash floods. So what happens is, if it rains, the water level just rises abruptly but immediately goes down, and that cannot sustain life. So we want to be able to have a finger on the pulse of a lot of the rivers in Kenya. So what we've been doing is we've been working at a conservancy known as Nyeri, and we've deployed sensors on a river known as the Nyeri in Kenya. It's a major river, and it's also one that serves the dry pastoralist areas in the northeastern part of our country. And so what we are trying to do is just deploy one of these sensors, and after we've really refined our prototype, be able to now determine things like the discharge, anomalies like flash flood, and then further improve the system to integrate hydrological models. So this system is based on LoRa, and I'll just describe briefly the architecture. So there's a LoRa model that sends data to the Things network, which then pulls. We're able to pull that data and put it on an influx database, and we visualize this data using a Dash application. So this is our Dash application. So this is the data we're able to get. So we're able to select the sensors we're interested in. We're able to see the level every 30 minutes. And sometimes you get anomalies like sensors going down, or because they're solar powered, and or gateways going down. Internet connections can be variable in our part. And what that means is the data we get can contain a lot of anomalies. So I'll just show you a plot of data between the 12th of May and the 15th, so a period of 3 days. And sometimes you just get erroneous values. So we notice that our sensor at night is particularly prone to just recording values close to 0. And then sometimes during the day it can really go high up, values that are anomalous. But then on the whole, it contains values that make some sense. So we can use machine learning in this particular case, just clustering, to determine the data that makes some sense to us. And that's what we've done in this particular application here. So in short, the data we collect will need to be put through machine learning pipelines to actually make sense of it. Because now what would happen is that you'd have this data average depth over a long period of time. And that, in conjunction with hydrological models, can actually tell you something about the discharge of that river. And if we monitor it over long enough, can actually detect anomalous trends. And that will allow us to make necessary intervention. So I think that was the last slide. In conclusion, what I want to say is that we can really, a lot of IoT systems, machine learning systems can be used in environmental applications. And we need to have very robust data processing pipelines, both in time series data like the water monitoring application I was talking about, or even the acoustic monitoring system where the data is noisy and we need to even deal with the noise before we can make sense of the data. And lastly, I think we are able to demonstrate that machine learning and IoT can make a huge contribution and really start making, at least stopping this trend of environmental degradation, which is leading to all these extreme weather events. If we can at least stop it, that can be something useful. And I think it's an important problem that we should put our heads towards. This is just a picture of me and a few of my colleagues that we went to collect data in the Mount Kenya forest. It's often tough, and we need, wild animals are always there. You need to go with an armed warden. But it's an important cause, and we believe with this data available, interesting applications can be developed. I really thank you very much for listening, and I look forward to your questions and maybe some interactions with you during the rest of the summit. Thank you very much.